my goodness gracious, we have learned so much about this already. So let's review some things that we know about prime and composite numbers. So, not prime or composite. What are our two special numbers that are not prime or composite? Or two very special numbers that are not prime or composite. Man, that's hard to read. Why is it so blurry? I'm sorry. Squint. Maybe that won't work either. You don't need to adjust your glasses. My camera seems to be bad. But our two special numbers that are not prime or composite are 0 and 1. Every other whole number that we will basically see in our whole entire lives can be either prime or composite, except for 0 and 1. Remember, if you were thinking about why can't 0 be prime or composite, let's take a look at our normal way of making a factor chart. All right, so this is not a stick figure. This is 0. Like our factor charts like this. It just looks funny because it kind of looks like a scarecrow. But okay, so how can we make 0 using multiplication? Well, that's not really how we make 0. 0 is just made because 0 is 0 of something. So that doesn't really work. So 0 can't be prime or composite because it has no factors. 0 has 0 factors. All right. How about 1? All right, let's think about 1 once again. It just does not look like. It just looks like we made a T. So this is a. Here we go. Now it looks like a 1. All right, there we go. So here's a 1, right? Now let's think of all the ways to make 1. 1 times 1 is the only way to make 1. But that's not two factors. That's just one factor. 1 is 1. So, according to our rules, prime numbers have to have two factors, one and itself, two factors, two different factors. All right, so maybe we should say different factors just to make that clear. Not that you can read that, but you're listening, right? Yeah, thumbs up. All right, so prime numbers have two different factors, one and the number itself, and then composite numbers have more than two factors. So 0 has no factors, 1 has one factor, so neither one of these numbers are prime or composite, all right? So that is a little hint about prime and composite numbers. Now, let's go ahead and take a look at some larger numbers today involving prime and composite. So, they want us to look at 21, 39, 57, and 93. All right, so 21. All right, we could draw arrays. We could start off by saying 1 times 21, right? But as you can see, once we're getting to bigger numbers, it's going to get harder to draw an array, right? So you can start using area models instead, right? So here's just 1 times 21, right? 1 times 21. That's kind of like our array, but it's an area model now. Is there any other ways to make 21? If you were thinking of your math facts, can two groups make 21? No, odd numbers can never be split into two. In fact, odd numbers can't have an even factor. Odd numbers cannot have an even factor. So you can skip all the even numbers whenever you have an odd number. Odd numbers can't have an even factor. Odd numbers can't have an even factor. All right, so we can't split 21 into two groups because it's odd. It doesn't split evenly into two groups and make whole number groups. All right, but can we split 21 into three even groups? That we can do. 3 times 7, right? So if we're going to make an array for that, we could say 3 times 7. Once again, it's an area model. Making the array for real is going to take a little bit of effort. See, a little more difficult to make. So I would stick to the area model because it's pretty difficult to make some of these numbers. All right. Now, let's think if there are any other factors to 21. We can use only odd numbers. 5 won't work because 5 does not ever have a number that ends in 1. It ends in either 0 or 5. 7. Well, 7's already on our list. So if 7's already on our list, we found them all. There's only 4 factors to 21.